This is part 2 for chapter 7.3. Okay, so for this section, we need to know what it means to be mutually exclusive. And we say that two events are mutually exclusive if they cannot both occur. So for example, if A has occurred, then that means B cannot happen anymore, or the other way around. If B already occurred, then A cannot occur anymore. Okay, so what that means is the occurrence of each event excludes, okay, or automatically disallows the other event from happening. And in symbols, if we have something that is mutually exclusive, okay, that looks like this, meaning the intersection of two events. Okay, and in the previous example, we realized that this is just the same as this. Okay, if they are mutually exclusive, the intersection should equal 0. Now in class we worked on investigation 9, and if you recall, I asked you guys to identify which among the 4 Venn diagrams do you think represents something that is mutually exclusive. So here, okay, these are the 4 examples, and I think everyone agreed that the second one, class of 2018, would be the Venn diagram that represents mutual exclusivity, and that is correct. If you have 2 events that are mutually exclusive, by the remark, the intersection must equal 0, and hence there should be no overlap between the groups in question. Okay, so that's and then of course we have complementary events. You should have been exposed to that, or you should have recognized that while doing the investigation. Okay, and for the complement of an event, so for example, if I have the probability of A, if I add its complement, the answer should always be 1. Okay, that I think we also recognize from the investigation. Anyway, so moving on to example 10 here, from your textbook. Katerina explores the names of students in her class of 15 students. So take note of important details. In this case, the total number of students, which is 15. And then we have 2 groups, group A and group B. Okay, and then group A, we're given names of students, and then it's telling us that these are the ones with exactly 2 vowels for group A, and then for group B, you have 3 vowels in their given name. Now, for this example, to avoid confusion, because there might be an issue as to how do you count the vowels. Are you looking at the distinct vowels, or are you just looking, regardless of whether the vowels are repeated or not? Now, we had a little bit of a discussion in class, but to be safe, as I also said earlier, just focus on the list already provided. Okay, so for example, if it's telling us that for group A, these are the elements of the group, okay, then just stick to Clara, Thomas, Fang, Urea, James for group A, for instance. Okay, you might argue that, for example, in group B, the A's are repeated, so did they count it twice or did they not? Okay, to avoid confusion, let's just stick to the elements given in the example. Okay, so that we would be able to just follow according to what the book provided. Okay, anyway, so for letter A, we have the following. We're asked to represent this through a Venn diagram. Now, I will not redraw that. I'll just use the book here as a reference. Okay, so this is how your Venn diagram must look like. You are looking at groups A and B. The reason why this is mutually exclusive, and that actually answers letter C already, is, if you think about it, it's not possible to have both 2 and 3 vowels in your name. It's either you have 2 or 3, at least for this example, and hence this is how our Venn diagram would look like. Okay, now for letter B, what is the probability of selecting a student that belongs to group A? Well, that's 5/15, because we know earlier we were told that there are 15 students, and in group A, from the elements provided, we should have 5. So 5 over 15 simplifies to 1/3. That's for the probability of A. For the probability of B, same thing. 15 students in total, and then you have 6 belonging to that group, simplified down to 2 over 5. Now, if you look at the intersection, okay, it equals 0. And this here is your reasoning explaining why it is indeed mutually exclusive. And that would be for letter C. Okay. And then for letter D, we have the union. Now, what I tell you is when you're looking for the union, all you have to do is just add all of the separate parts. Okay. In this case, there are no overlaps, sorry. So all you have to do is add the 5 plus the 6 and over the same total, which is 15. And that should give you 11 over 15. Okay, so that I think is pretty straightforward. Moving on to example 11, which is a continuation of example 10. So same total number of students, and we are told that for the third group, these are the students with at least one sibling, and then we have the names listed for us. So we're asked now to draw sets B and C. So notice what sets they're asking us to include. We're not asked to include A, at least for this one. We're just asked to draw sets B and C. Now, the drawing is here, okay? Again, we are sticking to the elements listed, okay? Regardless of whether we might argue that, well, Alexandra has 3 A's and 1 E, okay? Or, I don't know, Isabella has 3 vowels, you could say, if you count the A twice. Or again, it really depends, because I know there were questions in class earlier about the number of vowels and whether they're repeated or not. In that case, you would obviously move it, but again, sticking to the list provided, this is how your Venn diagram should look like. Okay, the intersection will consist of Oliver and Ricardo. Okay, that's no question, because we know for sure that they have siblings, at least one sibling, according to the given, and then they would belong to group B, which, if I remember correctly, is the group with exactly 3 vowels in their given name. Okay, exactly 3 vowels. Okay, so anyway, so that is how the Venn diagram should look like. And then if you're asked to find the probability of B, you will look at all the elements of B and then over the total number of students, which should still be 15. Okay, so I'll move on to the next page. You may still refer to your textbook if you want to look at the original question while watching this video. Same goes for C. You'll be looking at the circle, the C circle. Notice that there are 6 elements there, and then in the intersection there should only be 2 according to this one. Okay, notice that there are only 2 names in the intersection. Okay, anyway, and then this one, because there is an intersection, we say that they are not mutually exclusive, and this is how you write it out in symbols. And then in the union, now the reason your textbook subtracts this is because if they don't, okay, going back to this, you will be repeating these names if they don't subtract. But for me, what you could also do, alternative way of doing this, is just list out each of the parts separately. So I'm referring to the Venn diagram on page 323. What I would do is I would just do 4 over 15. So the 4 are the names in the B circle, plus the 2 names in the intersection. Okay, this is the number in the intersection. And then you have the other 4 names in group C. Okay, so this is how you get the union. You just add each of all of the parts together, and this should still give us 10 over 15, and that is indeed what is in the textbook, which simplifies, of course, to 2 over 3. Okay, so now actually that we went over this, or I've recorded myself. Okay. I think just to clarify a confusion we had earlier in class. Okay, if we count carefully, Alexandra, if I include the repeated vowels, has 1, 2, 3, 4 vowels, and that's the reason why it's not in the B group, because the B group says exactly 3 vowels. So they are indeed counting the repeats. Okay, and I think we didn't count properly, I guess, in class, but even the name Isabella, I, A, E and A, so that's 4. That shouldn't be in the B group. So I don't think there's anything wrong with the example. But then again, if you do encounter issues, as I said earlier, just stick to the provided list should that occur, just to be safe.